And now we will talk about porosity. Okay, so porosity maybe you already learned from reservoir engineering lecture, and it's a quite simple parameter. So if you have this model of rock here, the total volume is bulk volume. We call it bulk volume. And then you see here, these balls are the grain, rock grain, and the volume of it we call grain volume. And you see the pores or the spaces, okay, between the grains, we call it pore volume. The space or the voids, the volume of it, the volume of the voids is pore volume. So here you can see another picture of rock grain. The void, the space between the grains is the pores, and the volume of it, we call it pore volume. Okay, so you can see this rock, we have these big holes. Maybe this is the fog, but we have porosity, or we have pores within this rock. And the mathematical formula, it's quite simple. So this is the symbol of porosity. It is the bulk volume minus the grain volume, all divided by the bulk volume, or we can also say pore volume divided by the bulk volume. And this table is the typical porosity for different lithologies. So you can see for diatomite and chalk, we can achieve 50 to 60% the porosity. For clean sandstone, maybe 25 to 30%. Typical sandstone, 15 to 25. So you can use this as a rule of thumb if you are not so sure about your porosity. Shelly sandstone, 5 to 15. Tight gas, 5 to 12. Limestone can be quite small, but can be big porosity also, 2 to 15. Fractured cell, and then coal bed methane. You can see these numbers. These are the typical values. Okay, only the typical. So maybe you need to check in case by case basis. There can be different, but this is the typical values. All right, this is another representation. We have this one, total volume of reservoir rock, or we can also call it bulk volume, the total volume of the rock. And we have grain volume, or another term, matrix volume. Okay, so bulk volume minus the grain or the matrix volume is the pore volume, VP. Okay, yeah, based on the origin of the porosity, we can divide porosity into two categories. The first one is primary porosity, and the second one is the secondary porosity. Primary porosity, present at the time of deposit, okay, present at the time the rock is deposited, okay, thousands years ago, okay, or many geologists say million years ago when the rock was deposited, okay. And usually primary porosity is quite homogeneous. But secondary porosity, it is generated due to alterations that occur after deposition, okay. So it is not generated during the deposition time, but after that, okay. And usually it is heterogeneous, so the porosity at one place will be different from another place, okay. Yeah, for example, if you have reservoir here, and this reservoir suffers chemical process, geological process that will create secondary porosity, then the porosity in this zone can be different with the porosity in that zone. So this is the zone 1, zone 2. They can have different porosities because secondary porosity is heterogeneous. We find it in terms of fractures, fissures, joint, solution flux, dolomitization. All of them result in secondary porosity. And it can be matrix and fracture porosity. So these are the primary and secondary porosities.